here we go.
Okay. Hello, everyone. I'll be your host today, so let's just give about a minute as people sign in and get ready. We'll go ahead and start it in about a minute. We'll just wait for more people to sign in. Hello, my name is Don. I'll be the moderator for today.
And hello, everybody. My name is Michael. I will be running this demo today.
Okay, so I see people are signing in. That is good. That is good. Welcome, guys. We'll get started just in a bit. Let's just let more people sign in and get ready. Today's theme is Excel to Pandas and back with Michael Cullan. So I'll go ahead and introduce what we do here at Pragmatic, and Michael, just in a bit, we'll let more people sign in. And let's start transitioning into the presentation. You guys may not have caught, but my name is Don Fox. I'm one of the instructors here at Pragmatic Institute. We here at Pragmatic Institute teach courses in product management and product development, but we also teach courses in data science, ranging from the basics of Python all the way to AI and deep learning with TensorFlow. I'm one of the instructors on the data side. Here today we have Michael Cullan, which will be leading this presentation called Excel and Pandas and Back. And Michael teaches, let me give you a little background about Michael. He holds a master's in statistics from Arizona State University, and he has over 3 years of research experience building software for statistics and artificial intelligence. Here at Pragmatic, Michael teaches hands-on courses in topics ranging from the basics all the way to deep learning with TensorFlow and artificial intelligence. And today, Michael is going to demonstrate Pandas, a popular Python package that can improve your existing workflows in Excel. He will give that presentation, and there'll be some time at the end for some questions that I will moderate. So if you have questions throughout the presentation, feel free to put it in the chat. I'll say hello here. I'll see that chat. So feel free to post your questions. We'll moderate that. So with that said, I'm going to kick it off to Michael.
All right. Thanks so much, Don. So welcome, everybody. My name is Michael Cullan. As Don mentioned, I'm also one of the data science instructors here with Pragmatic Institute. And Don, I apologize. I think I gave you my previous blurb for Excel to Pandas Part 1.
Sorry.
No, not at all, for what we were going to be covering last time. Today, we're actually going to look a little bit at the other side of the equation. So, working in Python and taking our results back into Excel. Now, we're going to be working from Jupyter Notebooks today, and I have a link here to a binder repository so that you can launch an interactive notebook in your browser and follow along. Go ahead and paste in the chat. So if you click this link, this will take you to, so it may just actually build right away. This will take you to a page that's going to try to fire up a binder server for you, which will let you follow along with the Jupyter Notebooks as we go. And I'm going to go ahead and start sharing my screen. So if you clicked that link, you'd probably see something like the above. Make this window a little bit more wide, too wide. You should see something like this. You'll see this repo is building. It's like it's taking just a little while to build. Once this runs, you should end up, perhaps this one is built. Oh, and still building. Well, I'll show you what you'd end up with on my own machine where I'll be running it from. You will end up something that looks quite like this, Jupyter Notebook file browser. We're going to be running out of this OpenPIExcel demo today. So I'm going to fire that up, and I may have to scrub the outputs because I was looking through this a second ago. Oh, we're good. Okay. So a little bit about today. If you were at the last one of these, which I believe was 2 or perhaps 3 weeks ago, we talked about using pandas to sort of take data analysis to the next level, from Excel into something more flexible, more powerful, and that just affords us a lot more possibilities for extracting meaning from data. We briefly took a look at how we can, after doing all this analysis, technically we can output something back into an Excel file, although it's not exactly pretty. And while pandas is really the de facto tool, it's kind of the gold standard for descriptive analysis in Python, it doesn't fit every single job, because sometimes we need to work really with Excel as Excel. And so today we're going to be talking about OpenPIExcel, which is a library that lets us read and write Excel files more natively in some regard, or with more, while preserving more of the actual file itself. This link here will just take us to the, takes us to the wrong thing. Never mind. I'm just going to link to the documentation, but I can send out a link for that later. Okay, so as I mentioned, pandas gives us a lot of really powerful stuff for manipulating data, transforming data, and analyzing data. But we're going to look at some other workflows today. So OpenPIExcel gives us access to much of what we would use Microsoft Excel for. We can, format spreadsheets. We can create new pages and sheets and so forth. We can, use Excel formulas, and we can even create charts through Python and OpenPIExcel. And this is really just scratching the surface. Another really remarkable thing about this library is that it still works even if we're running on something that doesn't have Excel. So this is great, for instance, if we were building an app that generated automatic reports, perhaps was running on a Linux system, maybe in a little container. We could also use OpenPIExcel for other things, though. We could have it read a whole bunch of spreadsheets and ensure that they all fit some template that we've defined, or they all have some relevant pieces of data in certain places. And we could also do something like load in a spreadsheet, make some modifications to its structure, create some new rows, columns, or cells, change formatting, and all those kinds of things. So our focus for today is going to be on just that, modifying a spreadsheet programmatically. Now, I've included screenshots of our spreadsheets for today because it's going to be a little bit easier than watching me flip-flop between my Jupyter notebook and like 5 different Excel files. So we're just going to be taking a look at our spreadsheets this way, but I guarantee you after when we run this code, it will output these files. You can download it to your own machine and see what it would look like when you do that. So here is our example. This sidebar, perhaps toggle these a little bit better. So we have this spreadsheet, and it is basically telling us, tracking a blog marketing campaign. So these are some hypothetical blog titles I might have written. They're about pandas, perhaps, some dates they might have come out, and what traffic might have looked like. Not too much to say on the actual content of this. It's just an example. But what we're going to do today is, let's say this big merged cell right here, A10. This has some relevant data that we might want, but which is perhaps not in a very convenient form in this table. So what we're going to do is we're going to extract the data in A10. We're going to get the period, March 2020. We're going to get the campaign, which is tutorials, and we're going to get the run date, which is April 30th, 2020. We're going to take all of those. We're going to create 3 new columns on the right-hand side of the table at the bottom, and we're going to populate those columns with these values. And then, of course, we're going to make sure that we populate the right cell formatting across all those new cells. If I wanted to do this just on this file, it would take me 2 seconds. Certainly would be easier than writing code to do it. However, if we had, perhaps dozens, hundreds, or even thousands of automatically generated files, and we wanted to make some small modifications like this, this is really where OpenPIExcel shines. And I will say, by the way, that the example for today comes from a question that I had coming off of the last tutorial. Someone gave me a spreadsheet in a very, very similar format to this one, looking to do this task. So I've just sort of rearranged or sort of repopulated the data with sort of example data, and we're kind of going from there. So why doesn't pandas work for this? Last time around, we saw how it could read Excel files, write to Excel files, and so forth. But we can also see that while pandas is very good at reading a single table from an Excel file, when we have something like above, which is more of a document, rather than just data, the representation gets a little bit not necessarily unexpected. I mean, it is a pretty literal representation of what's above, but we can see that the utility of pandas starts breaking down pretty quickly. So this is what our data frame looks like when we load it right in from into pandas. Okay, well, what happens if we try to write it back out to Excel? Perhaps while this doesn't look that useful, maybe it's going to write back in a way that's still faithfully preserving the original file. And if that was our hope, those hopes have been squashed, as we can see. Pandas scrubs away, ignores all of the formatting when it reads from Excel. And when it writes back to Excel, it writes in this very, very simplified manner. We have these index labels, which are not great. We have these column labels, which are also not great. We've gotten rid of all of the column widths as before, so all of our text is smashed together. We don't have any of the fonts. We don't have the fill colors and the borders. And to some degree, we can modify these things manually in pandas. But because we want to make a small change to an existing document without reinventing the wheel, it's not going to do that well. Now, I showed this particular example to say that here we've done nothing. We've literally just read from Excel and written back to Excel with no additional arguments. But I will point out we can do a little bit better right off the bat if we just get rid of the header and those index values. This starts looking a lot more like our original file. But again, we've gotten rid of all that nice formatting that we do want to preserve. So why does pandas do this? I mean, why would they get rid of information that was there? Ultimately, this is because pandas is not built for working with Excel specifically. It's built for analyzing data. And as such, the main focus is on efficient computation, efficient representation of data, with regards to being computationally efficient, as well as not taking up too much space in memory and generating really large files. And again, this is where OpenPIExcel comes in. So a bit on the pros and cons here, because I certainly would not recommend OpenPIExcel for every job. Across the board, pandas is probably more likely going to be useful, especially if we're, again, analyzing data. But when we need to generate really nice spreadsheets or modify spreadsheets in a nice manner, OpenPIExcel is great. That being said, OpenPIExcel is very memory intensive. For instance, I think the documentation mentioned that even something as small as a 50 megabyte spreadsheet might use 2.5 gigabytes of memory when working in OpenPIExcel, because it has to keep track of a lot of different data and metadata for all the different cells. And because since it's not running Excel to represent the file, it's having to maintain the state of this entire spreadsheet all at once. So it is doing a lot of heavy lifting. And as a result, OpenPIExcel is really only going to be useful when we're working with lots of small files, like the ones that we saw above. These sort of, little just summaries that we might need to modify a little bit. We're not working with, thousands, tens of thousands, hundreds of thousands of rows of data. We're really just modifying documents. That's going to be a much more common and useful workflow for OpenPIExcel. That being said, there certainly are cases where we might want to use these two libraries in conjunction with each other. Perhaps we are performing some analysis in Python, or I'm sorry, in pandas, and we want to write that out to a report in Excel, but we want it to look, particularly nice, and we might then write a file using OpenPIExcel with data that we've generated in pandas. But that's going to be outside of the scope of today's course or of today's demo. Okay, so all that being said, how do we actually work with this library? Generally speaking, there's three sort of abstractions that we're going to be working with. OpenPIExcel is an object-oriented approach to representing workbooks, sheets, and cells, which have sort of the very natural analogs in Excel. They are what you expect them to be. So we're going to load in a workbook. This is our Excel file, just using this load workbook function. And then we're going to specify this variable sheet as the currently active sheet in that workbook. So when we open the workbook, whatever sheet is visible, that's going to be the active one. And that's what sheet is right now. And before we do anything else, I just want to demonstrate that we can save this back out. We've made no modifications. We've simply opened it and saved it back. But now we have a screenshot of the new file, OpenPIExcel.xlsx, that we just saved from this notebook. And we see that it looks exactly the same. Perhaps not that exciting, but just some proof of concept that this will preserve formatting while pandas will not. We even have our merged cells and everything. I'd also like to say that just a word of caution, especially if you're working interactively, when you are done with a workbook, to call the close method, which will free up memory. As I mentioned, OpenPIExcel, very, very memory intensive. Okay, so that's getting the workbook open, getting the sheet that we want, writing a file, closing the workbook back up. Let's get into the interesting stuff. So as I mentioned, we wanted to get this data right here from A10. We want the period, the campaign, and the run date. So we'll load that workbook back in since I just closed it. And now that we have our sheet, we can extract a cell object from that sheet. Works just like a dictionary lookup in Python. There's going to be some additional syntax we can use for specifying things like cell ranges, which we'll see later. But generally, these square brackets and then the cell that we want, A10. So we can look at how that cell is represented. It says, this is a Python object. A10 comes from sheet 1. And we can look at some of the things that cell contains. So we can get the coordinate, which is going to be where it is. Of course, that is A10. We can get the value inside of the cell. So cell.value is what we're working with here. And when we print this out, we see that we have what we would expect. Or starting here, rather. We have the period, 2020 March. We have the campaign, tutorials. We have the run date, 4/30/2020. Seems good so far. Let's take this value. We're going to write it to a new variable called s. And we'll take a look at what s contains. And something strange might have happened here. So we have these sort of unexpected little sequences, \xa0, that we now need to clean out of the string. So these are I believe non-escaping or perhaps non-breaking white space character in UTF-8. And this tells us basically that the value was decoded incorrectly, which is not a big deal for us. It just means that we have a little bit more that we need to do as far as getting this string to look the way that it should. We need to replace these with standard white space. And this is very easy to do using Python's built-in Unicode data module. We're just going to use this normalize function. And the other thing that we want to do after we normalize, note that we have this space at the beginning. We just want to strip off any white space on either side. So I just wrote a little function here, clean text, and that's going to do just that. We pass in our text. It's going to normalize all of these Unicode spaces to regular spaces. And it's going to get rid of any leading and trailing white space. So what does this look like? So if we assign this new variable text to the output of clean text, putting in our original string, we get this, just what we were hoping to see. And now we have basically a good starting point to get the information we actually want. The task now is how do we get this piece of information, this piece of information, and this piece of information in a reliable way. We want to make sure it's as reliable as possible because, again, we want to automate this potentially over many, many, many different spreadsheets. We don't know necessarily what the period, campaign, or run date might say. So we want to be as general as possible in specifying a pattern. And the tool for the job here, we're going to make quick use of regular expressions to define this pattern and parse this cell or value of this cell in our spreadsheet for those pieces of information. Now, regex is a very sophisticated topic. It's very powerful, it's very flexible, and it's very widely used, but it's also very beyond the scope of today's demo. And even if we were only doing regex, we probably couldn't cover very much of it in 30 minutes. So I won't get too much into how we're doing this or what this syntax means, but I will say that what this string we see here in red, this is the specification of our regular expression. And we can see that this basically describes the pattern that we're looking for. Just visually, that becomes pretty clear off the bat. We have a period, we have a campaign, we have a run date, we have some other stuff in here. And what these little chunks tell us, what these are telling regex is that right here, these parentheses say there's a pattern, and I want to capture that pattern. And the period asterisk just say, just capture whatever happens in between here and here. Capture whatever happens in between here and here. Capture whatever happens at the end after run date and a space. So we're going to get those into separate strings now. And I'm writing another little function for that that's going to do just that. So if we call get fields on our cleaned text, again, that's what we had above, it's going to give us a little list of, or a little tuple of strings rather. And it contains what we were looking for, 2020 March, tutorials, 4/30/2020. I'm going to assign these, of course, to separate variables. Now we have our period, our campaign, and our run date. So at this point, we have all of the data that we need. We've done all the necessary manipulations, and we can now start writing back into that worksheet we've been working with. And so there's a few ways that we can do this. We can assign a value to a single cell, just like we would assign a value to a dictionary key. So from our sheet, we could say I12 should say period, J12 should say campaign, K12 should say run date. Looking back up, scrolling really quickly, that kind of checks out. Into row 12, we have our table headers. And we see, I, so we want, or H right here, so we want IJK for our next 3 columns. And so that's what we're doing right here. We're specifying those header values one by one. And we've done so using the typical Excel notation, a letter for the column and then a number for the row. But OpenPIExcel also allows us to access cells numerically via a numerical index. And in some cases, this might be more useful for us. So for instance, instead of saying I, we can say column 9. And to get that value, we certainly could have done A, B, C, D, E, F, G, H, I. But rather than sit around and do that every time, we can use this column index from string function in the OpenPIExcel utilities module. And so then we just pass in a letter and it tells us the relevant, the the correct column value. This is also nice because if we had something like, a much longer one of these, and we were getting into, multiple digits so to speak, I guess, of letters, a very large spreadsheet, column index from string will still do that for us as well. And I will also note that this should say column and then row. So from our sheet, we can call the cell method, and we can specify a column and then a row. So really just like we've done above, column and then row, but now it's numerical. And we can pull the value from there. So there might not be anything. I guess this is row column. It might have been working column row for me recently. Maybe I was using a previous version of the package. Okay, so rather it is row and then column, which is more typical of how we would work with a table or a matrix numerically. I will also note that this is going to be 1 indexed rather than Python's typical 0 indexing. So A1 is 1, 1 here rather than something like 0, 0. Didn't run that cell, that's what happened there. That's why, okay. So here we've pulled out the value of at I12. So row 12, column I, that says, that's the column header for period, just like we assigned above. So that's great if we want to, so this was great if we wanted to assign a single cell, but it's not going to be very useful for, we need to assign values for multiple cells. The way that we would do this in OpenPIExcel is to iterate over cell objects. So, for instance, you iterate over the indices and access the cells at those indices. And so this is where the numerical notation becomes very useful, because we can just iterate over, the relevant rows, the relevant columns to get the cells that we actually are interested in. And to make our lives more convenient, OpenPIExcel also gives us another utility function, range boundaries, which allows us to specify a range the way we typically would in Excel, which is A1 through D3. And it gives us this tuple of the starting column, the starting row, the ending column, and the ending row for that range. So this goes right from columns 1 through 4, A, B, C, D, and of course rows 1 through 3. And so we can use these to specify numerically basically that rectangle of that range that we can then fill in. Now, to speed this up a little bit, I've written a function here called fillRange. And so we're going to pass in the sheet that we're modifying, the string for the range that we want to modify, so for instance, A1 through D3, and then the value we want to populate all those cells with. So from this range string, we're going to get those boundaries. We're going to turn those into a starting column, a starting row, an ending column, and an ending row. And then we're going to iterate over those. And as we iterate over the rows and columns that we've specified in our range string, we're just going to populate all those cells with the value that we passed into the function. So what does this do for us? Well, now we can fill in those 3 cells, I13 through I15, with the relevant period, which, as you might recall, was 2020 March. The relevant campaign in column J, which is tutorials, and the relevant run date in column K, which was April 30th, 2020. So we're just saying fill this range onto the worksheet I've defined as the variable sheet, Here's the range we want. Here's the value I want in all those cells. And we can save that workbook. And here's a screenshot of what we get out. This is the wrong screenshot. In fact, because that should not be formatted yet. Such is life. So what we would have seen here was that all this data would have been here, but we would not have had the appropriate fill colors and borders and the like. So let's now address how we do that. And in OpenPIExcel, we can do a lot of really, really rich and sophisticated stuff with regards to formatting cells. And we can really do this from the ground up. And we can modify a lot of things individually. We can specify fonts, text alignment, right, left, right, and center, and justified, and so forth. We can specify number styles, if something should be a percentage, if it should be, a monetary value, how many digits of precision it should have, scientific notation, all these sorts of things. We can even define custom number styles. We can do conditional formatting, such as highlighting negative numbers in red, for instance. We can specify the cell borders. We can specify fill colors. And again, this can be just static or it could be conditional. And this is, again, just really scratching the surface. Of course, we can also do things like change the width of columns. We can merge and unmerge cells. We can add buttons for filtering and sorting columns. It really goes on and on. But here we're just looking at a little bit on styling cells. And while these can all be modified individually, we're going to focus on sort of the most basic task, which is just taking the formatting from one cell, copying it to another or to a range of cells. So what we wanted to do, which is also reflected in this screenshot, unfortunately, is all of these cells would have had no formatting. They would have just been white background. They wouldn't have the correct text alignment. The fonts would have been different and so forth. And we just want to, take the style of this cell and populate it to the right. We want to take the style of these cells and populate them to the right. And that's just what we're going to do. And so here I've written another function to do just this. So copy a style to a given range. Specifying our sheet as before. We're going to pass in a coordinate for the cell that we want to take the style from. And then we're going to pass in a range of cells as our destination to paste that style onto. And I won't cover all of this code, but essentially what happens is we give that source coordinate, for instance, h12. That's going to become a tuple of the column and then the row. And from there, we will select the appropriate cell based on that column and row. So now we have our source cell. We can get the style from that cell. We're going to define the range boundaries just as we did before, using that range boundaries function to get our starting column and row, our ending column and row. We're going to iterate over those rows and columns as before. And what really is happening, so we're specifying this destination cell just to be the cell occurring at the current row and column. And we're going to assign the style attribute, and this is an underscore attribute, so it's technically kind of a hidden attribute, but we're modifying it directly. We're going to modify that to be a copy of the style from the original source cell. So if we were copying H12 onto I12 through K12, this is going to be H12. And we'd be copying, this is going to be H12, and we'd be copying that fill and alignment and font across, right? So we'd take this, grab the style attribute, and then modify the style attribute on these three cells. And so what we do is from H12, which is one of our header cells, we fix the rest of the headers. From H13, which is one of our data cells, we fix the rest of the data in that entire rectangle. And then from H16, which is that was our bottom row, which had some aggregated totals for the engagement for those different posts. We're just gonna populate that fill color across to make it look a little bit more normalized. And once again, after doing all of that, we can save out an Excel file. We can close the workbook, and this is what we're going to see at the end. And we did technically just see this, I know, but what we just did in the above cells was to take this style, this first 28 days cell, use that style and paste it into these 3 cells, take the style from this particular cell, paste it through these 9 cells, and take the style from this cell and paste it through these 3 cells. And if we wanted to, we certainly could have gotten more in depth, for instance, with treating 4/30/2020 as a as a date, or maybe modifying the way we displayed that date. Same for the period, and we could have really done any other styling we wanted to for these data cells as well. But we were just sort of trying to preserve the original styling of the table, just make it look nice and cohesive. And so we just are finishing out there. And there you have it. That is modifying a single file with OpenPIExcel. Again, our motivation here was not that we could write a bunch of code to do something to one Excel file that it would take 2 seconds to do manually. But rather, we can imagine a workflow in which we have to do this, again, to dozens or hundreds of different files, and it becomes inconvenient or intractable to do it manually. And we could write a little script that just does everything we just did and just run that automatically through our whole list of source files and get these nicely modified and nicely formatted results. And that's going to close things up for me. I will point out very quickly that back in the directory where we opened the notebook from, if we look in outputs, we do have all of the Excel files that were generated. And you certainly can open these up and they will look as we expected them to. I'm going to take a few minutes for questions in just a second here. But I would be remiss not to mention just a little bit more on our data science coursework, which Dawn mentioned a little bit at the beginning of the class, just sort of some of the things that we offer. And so with regards to Pragmatic's public courses, we have a core curriculum for data science right now, starting with this Essential Data Tools course. This is really getting up and running with descriptive analysis and some automation and string processing and regular expressions like we saw before in Python using pandas. So this is a lot of these sort of blanks that were left to be filled in, so to speak, in today's demo, such as how that regular expression worked for pulling that data out, or if we wanted to do more stuff in pandas, or how we would actually automate that task. This is going to be covered in Essential Data Tools. From there, we get into our machine learning class, Practical Machine Learning, which is going to teach the fundamentals both on the relevant theory as well as the tools and techniques we typically use as data scientists doing machine learning with Python in the real world. We build classification models. We check to make sure we're not overfitting. We do clustering, and all of this we do with real world data and real world motivations. And so that's our practical machine learning course. And these are intended, so Essential Data Tools, this is intended for someone who has some experience with Python, perhaps not a whole lot, but has written some code before, maybe understands the basics of a little bit of numerical computation and things like that. That is a prereq for our machine learning course. And for a primer course, we currently offer a live 3-hour session Intro to Python course where you write actual Python code and actually build a machine learning example with natural language processing over the course of those 3 hours. So this is our live session. We also, I guess, yeah, so that is our basically current core curriculum for for data science in Python. So that being said, thanks everyone for listening. I'm going to take 5 minutes now to address questions from the chat.
Yeah, guys, if you didn't see my chat, go ahead and feel free to post your questions on the Zoom chat. I posted something right there. Post your questions there. I'll take those and I will pass them on to Michael so he can answer them. The floor is open, so feel free to post your questions. Okay, so if there are no questions, we can wrap it up. But any last call for questions, post them on the chat and I will pass those. I'll read them to Michael. I see a question has appeared. So let me go ahead and take a look at that. So if there is an addition macro that is updating cell values async, can we record that? Is there an adding macro that is updating cell values asynchronously, and can we record that? That's the first question someone posted.
I don't actually, I might need a little bit of clarification here. Is the question here, this is a macro that is in the file already? Or this is a question about if this functionality exists as something that we could, updating those values would be in OpenPIExcel. I'm not sure if live market data coming into Excel. So you would not be able to continuously update a OpenPIExcel workbook as live data comes in to Excel unless you were just repeatedly calling workbook or repeatedly calling load workbook, which I suppose you could do. But natively, once you load in a workbook, it is now represented in Python, in OpenPIExcel. There isn't like an open file connection to Excel or anything like that. So you would have to be repeatedly saving the Excel file and repeatedly opening it in OpenPIExcel.
Okay, so we have one more question. I'm going before we wrap up. So this question is, for this tutorial, I'm having a hard time opening the output Excel file. And if someone can mute themselves, that'd be great. I hear some feedback. So take the time to mute yourself. Thank you. Okay, so someone is asking, for this tutorial, I'm having a hard time opening the output Excel file, getting an error saying the file is not UTF encoded. Did I miss something upon saving?
It is possible that that has to do with the file being, that may be because it was output through, or that it was written from the Linux machine that the binder notebook runs on. It may be because it's likely that. I need to look into this a little bit more because I developed this locally on my own machine. But I will look into this, and if you want to send us an email, Alyssa, I can follow up.
All right, thank you. So thank you everyone who came for today's event and posting your questions. Thank you, Michael, for taking the time and giving us the presentation from Python to Excel. With that said, take care, guys, and hopefully you'll tune in for the next thing we have. See you guys.
Thanks, everyone, and thanks, Don, for moderating.